Welcome back. So in this video, we're continuing with Chapter 2 from Core's The Economy 2.0, and we're going to talk about inequality. And we're going to talk about different ways that we can represent inequality graphically, but then also numerically. And so let's jump right in. We'll start, with a basic example, and then we'll introduce how we can sort of look at our wage setting and price setting model and how it relates to inequality. So the first thing that we want to do is graph inequality. So when we are talking about inequality in economics, we can be talking about a number of things, right? One thing we can be discussing is income inequality. So how much income each person has compared to each other. We can talk about wealth inequality. So wealth is what you own. So that can include, your house or land, which is one of the examples we're going to give here. Or it could include, financial assets as well. So stocks and bonds and things like that. In general, wealth inequality is always greater than income inequality. And we'll see that in our two examples on this page. So how are we going to graph this? Well, in order to graph it, we need to know sort of how much each person or each, group has. And so we're going to, on the horizontal axis, line up everybody from poorest to richest. And we'll just call, we'll say it's in percentages. So we'll go from 0 at the origin, right, which is always where we start. And we'll end up at 100% over here. And so in this case, what we're graphing is land ownership. And what we're saying is that the bottom 90% of people don't own any land. And so our Lorenz curve is just flat here on the horizontal axis. And then the top 10% own all of the land, but equally. And so we just get a straight line going from 90 all the way up to 100. And what's here on the vertical axis is cumulative share of whatever we're measuring. So in this case, it's the cumulative share of land. And so we're cumulative, meaning we're adding it up as we go along, right? And so we will always start here at 0 and 0 because 0% of the people own 0% of the land, 0% of the people have 0% of the income, and we will always end up here at the top right because 100% of the people always own 100% of the land, 100% of the income, 100% of the wealth, whatever we're measuring. And so in this case, you can see it's very unequal, right? We have most people who have no land, and then 10% of the people who own all the land. And what we're comparing that to is this line of perfect equality, or the 45-degree line. That is just a straight line from 0, 0 to 100, 100. And why we call that the line of perfect equality is that if everybody has the same amount, so if everybody had the same amount of land in this case, then our Lorenz curve, instead of being this line like we have here, would just be a line exactly on that line of perfect equality, right? And we can't get any higher than that. And so that's really what we're comparing our Lorenz curve to. And that's, as we'll see in the next slide, how we're going to calculate our Gini coefficient. So this is, not uncommon way that land used to be owned, right? Most people did not own land, and then it was held by some group of elites, whether we call those, landowners or nobles or whatever. Income is distributed more equally because most people are going to need some amount of income in order to eat. And so here on the right-hand side, we're graphing income inequality. And we have three different ships, two from the 17th or 18th century, and one from the 21st century. And so what we see is we have a pirate ship, Royal Rover, from back in the day, and a British Navy ship, Favorite, also from about the same time as the Royal Rover. And then we have the active British Navy from one ship. And what we can see is that, like, if we look at the active British Navy, there's a group of sailors that earn the same amount. They make up about 80% of the crew. And then we start getting higher pay, right? So we get higher pay. I don't know exactly what the British Navy calls them, but petty officers and then officers. And then we can see that the highest paid person on ship will be the captain, and it looks like they own or they earn a lot of the income, right? They earn maybe 25% of the income. What's interesting to note is that the active British Navy and the 18th or 17th century British Navy are very close, right? There's not that much difference. The active British Navy sailors get paid a little bit more, and so there's a little bit less inequality. But compared to the pirate ship, they're much more unequal. So with the pirate ship, basically what's happening is that most of the sailors are getting what they call a share, right? So an equal share. And then there's a few people that get either a share and a half or the captain gets 2 shares. But mostly the spoils are split fairly equally. And of course, probably the reason for that is that you're taking on a whole lot of risk if you become a pirate. And so you're going to have to be paid well in order to do that. Because of course, if this British Navy favorite catches you, you're all going to either be killed in action or hanged later. So what we can see from this example is that for the Lorenz curve, the closer the Lorenz curve is to that line of perfect equality, the more equal the distribution is. And the farther away it is from that line of perfect equality, then the more inequality we have. So in this example, the Royal Rover is the most equal distribution of income, then the British Navy, the active British Navy, and then the favorite. Although, of course, as we said, those two are pretty close. So now what we would like to have to go along with our Lorenz curves is some numerical way to represent inequality. And that's what we get from the Gini coefficient. And so the Gini coefficient turns our Lorenz curve into a number between 0 and 1, where 0 is perfect equality and 1 is perfect inequality. One person has everything. So let's go back to our landowner example and see how this Lorenz curve translates into the Gini coefficient. And then we'll do an example, a slightly more complicated example, but still pretty easy in calculating the Gini coefficient. So we're going to divide up our graph into 2 areas. The first area, which we'll call A, is the area between the Lorenz curve and the Gini coefficient. So in this case, it's very big, right? It's almost all of this bottom triangle. And then the other area is B, which is the area underneath the Lorenz curve to the horizontal and vertical axis. So in this case, if we use this A and B, our Gini coefficient, which will always be the same formula, is just A, the area of A, divided by the total area of A plus B. Now the good news is the area A plus B is always the same. So you can either calculate A or you can calculate B and then use B in order to calculate A, which is what we're going to do in the next example. Now we can see they've calculated the Gini coefficient for us in this case. It's 0.9. So A is 90% of A plus B. And 0.9 is very unequal, right? We're almost to 1. If, one person or 1% had that, owned all of the land, then we would basically be at a Gini coefficient of 1. Now, as I said earlier, wealth inequality tends to be higher than income inequality. I believe the pirate ship Rover from our previous slide, the Gini coefficient is only 0.06, right? So it's very close to perfect equality. So let's do an example where we actually calculate the Gini coefficient. And we'll just imagine there are 3 people, or you could imagine there's 3 groups that all earn the same and will come to the same thing. And so the bottom group earns $5,000, the second group earns $15,000, and the third group earns $30,000. And we're just assuming those groups are of equal size. And so in order to graph the Lorenz curve and then calculate the Gini coefficient, we're going to need to answer some questions. So the first is we have to figure out what is total income. That's pretty easy. We just add them up. What percent of total income does each earn? So with the percents, then we can start graphing on the vertical axis the cumulative percent of income. then we'll be able to draw the Lorenz curve. And then from there, we'll be able to calculate the Gini coefficient. So total income is easy, right? Total income is just 5,000 plus 15,000 plus 30,000. So that's 5 plus 15 is 20. 20 plus 30 is 50,000. What is total? So what percent of total income does each earn? Well, that's pretty easy too. 5 divided by 50 is 10%. 15 divided by 50 is 30%. And 30 divided by 50 is 60%. Now, what we need to graph is the cumulative, right? So that bottom third will be 10%. And then the bottom 2/3 will be 10% plus 30% or 40%. And then the 3/3, which of course is everybody, will just be 100%. So let's graph that, and then we will show how we can calculate the Gini coefficient in this case. Okay, so here on the horizontal axis is the cumulative amount of people from poorest to richest. So we've divided that up into thirds. So we have our bottom third, our second third, and then our last third. And then the bottom third earns 10%, right? That was the 5,000 divided by 50,000. So that's a point on our Lorenz curve. And then the next third earns 30%, but we want to add that to the 10%. So we get the cumulative amount of income for those bottom 2/3. So here is the point where this is the 2/3 of people, so 66.7%, and then 40% of cumulative income, 10% plus 30%. And then, of course, the last point is always going to be up here at 100. That last third earns 60% of the income. 60 plus 40 is 100%. Okay, so far so good. Now, we know that the Gini coefficient is A divided by A plus B. Now, the good news is A plus B is always the same. So it's always 1/2 times the base times the height. The base is always 100. The height is always 100 because it's 100% of people, 100% of income or wealth or whatever we're measuring. And so A plus B is always 1/2 times 100, which is just 5,000. Now, A here would be a little bit complicated to calculate. And so instead, we're going to calculate B, which is more straightforward. And we're just going to divide up B into 3 triangles and 2 rectangles. So the first triangle is here. And all of our triangles are going to have a base of 33.3. And then this triangle has a height of 60, 100 minus 40. And so the area then is 1/2 times 60 times 33.3. Our next triangle has the same base, 33.3, and a height of 30. So our area is 1/2 times 30 times 33.3. Remember that height comes from 40 minus 10. And then the last triangle, again, has a base of 33.3 and now a height of 10 minus 0. And so the area is 1/2 times 10 times 33.3. Now the first rectangle we're going to calculate is right here. And it looks almost like a square, but the base is 33.3. The height is 30, 40 minus 10. And so that's our first rectangle. And then the last rectangle is going to be down here. So it's going to have a base of 66.7 and a height of 10. And so that is just 10 times 66.7. And then if we just calculate all of these things, we get 1,000 plus 500 plus 166.7. Those are our triangles. Plus 1,000, that's the first rectangle. Plus 666.7, that's our second rectangle. We add it all together. We get the area of B is 3,333. Now, we want A, right? And so in order to get A, we need to subtract B from A plus B. A plus B is 5,000. B is 3,333. A then is 1,667. Now we can use that to calculate the Gini coefficient, which is A divided by A plus B. So 1,667 divided by 5,000, or 0.33. So you can see in this example, even though it feels like there's a fair amount of inequality, right? That top person is earning 30,000, 6 times as much as that poorest person. Our Gini coefficient is not that high. It's 0.33 compared to like the 0.9 we got in the land ownership. And as we'll see, 0.33 is actually a fairly low inequality for income. Now, one of the things that we might care about is not only sort of the amount of income that you earn in the market, right, is your wages and salaries, but also how much you actually have to spend. And so that will depend on what people pay in taxes and then what they get back from the government in terms of transfers. So transfers could be anything from unemployment benefits, SNAP benefits in the United States, right, to help you buy food, or other types of transfers. And so here we have an example, I think this is the Netherlands, where we have a Lorenz curve for market income, that's that bottom line. But then we also have a Lorenz curve for disposable income, that's that middle line. And they've calculated the Gini coefficients for us. The market Gini coefficient is 0.4, so a little bit higher than what we just calculated. And the disposable income Gini coefficient is 0.31. And so what that's saying is that in the Netherlands, the tax system makes things more equal, right? It will have a progressive tax system which taxes the rich more, gives some of that money to the poorer part, and that decreases inequality. And so you can see, if we just look at this bottom 10%, right? The bottom 10% have almost no market income. Very little market income, but they do have some disposable income. So they are given some income there, and that really reduces inequality. And so in many developed rich countries, right, and I'd say almost all really, the disposable income Gini coefficient is going to be less than the market income Gini coefficient. That's true in the United States. It's true in European countries. It's true in Japan. It varies, though, in terms of how much countries do. All right, so let's try to look at our wage setting and price setting model and how it relates to the Lorenz curve. And so here in our example, we have our wage and we have our profit. So remember, the wage goes from here, 0, to here, 0.6. And profit goes from 0.6 to 100 at our average product of labor. And so what we're assuming here, we're making a couple of assumptions. One is we're assuming that there's some people who are unemployed, and so they are here, we're going to assume just 10% unemployment, so they have no market income. Then we have 80% of people who are employed, and they are earning 0.6 of output. And then we have 10% who are the owners of the firms. And so they are earning the 0.4 of profit. Now, because there's only 10% of them, right, they're actually earning more than the 80%, even though the profit is 40% and the wages are 60%, right? But it has to be spread over a larger group for the wages and a smaller group for the owners. And so our Lorenz curve here is flat for that bottom 10% that aren't earning any income. And that's really not that unusual for most developed countries. There's going to be some bottom percent that are not earning any market income, whether that's 5% or 10% or 15%. Then we have a straight line because we're just assuming all workers earn the same amount, right? Which we know isn't realistic, but that's okay for our example. And then once we get to the owners, that line increases up, and of course we're at 100%. Now we could calculate this Gini coefficient. We could divide it up into, really we would just need two triangles, one here, and this rectangle here to calculate B. But good news, they've done it for us, and the Gini coefficient is 0.36. Very close to what we calculated in our example. So maybe we want to do something and decrease inequality, right? And so one example could be that we try to increase competition in the market. So what's going to happen if competition increases? Well, that's going to reduce the markup, right? Prices will fall. And because prices are lower, that means real wages go up. And so in this example, real wages have gone up from 0.6 of the product of labor, so 60% of the product of labor, to 79% of the product of labor. We've moved up our wage setting curve from A to B. Nothing has changed in the wage setting curve, right? That hasn't shifted. And now our unemployed, because we're producing more, right? So more people are going to be needed to work. Our unemployment has fallen from 10% to 7%. And so if we graph our new Lorenz curve, right, that's this blue line here. We go from 0 to 7. That's this people who are still unemployed that aren't earning any income. And we go up here now to 70% instead of 90%. And then the last 10%, the owners still get their profit, right? But that profit is lower. And in this case, our Gini coefficient has fallen from 0.36 to 0.17. And so what this is sort of emphasizing is that competition is hugely important because it increases the real wage. It might not do anything to the nominal wage, and I think that's important to understand, right? The nominal wage, the amount you get paid in dollars or pounds or pesos or rupees, could be exactly the same, but because prices are lower, the real wage is higher, and because we're producing more, right, the unemployment rate is lower. So in this case, increased competition decreases inequality. So we'll stop there and we'll do a few more examples of the wage setting and price setting curve and inequality. And then we'll start looking at some data and see, actually sometimes the data doesn't always agree with the model and we have to think about why that is.